Okay, in our previous segment, we learned that there were three ways that a radioactive nucleus changes into another nucleus. And so one way was by the emission of a beta particle whenever a neutron changes into a proton. And then another way that it can get rid of energy is by emitting the alpha particle, which was two protons and then two neutrons. So 2 plus 2 makes 4. And then the third mechanism was by just emitting energy in the form of a gamma ray. So on this slide, I wanted to show you how we can start with uranium-238, and I want you to see how it sequentially turns into different kinds of substances. So we're going to start with uranium-238, and on this graph, going up and down is going to be the mass number. So this is going to be the number of neutrons plus the number of protons in that particular nucleus. And then going sideways is going to be the atomic number, which is going to be the number of protons in that particular nucleus. And so we're beginning all the way up here in the corner with uranium, so that's the element, and then its total number is going to be 238, so that's the number that's over here. And then going down, the number is going to be 92. So uranium is 92. So down here, its atomic number is going to be 92, and then its total number of neutrons and protons is 238. So notice what the first reaction is it gives off an alpha particle. So what happens when uranium-238 gives off an alpha particle? So we're going to take 238 minus 4 is going to be 234. So did you see that it got a little bit lower? So now it's over here at 234 is its total. Okay, and then, well, what happened to the bottom number? So the bottom number is going to be 92 minus 2 is 90. So that means it moved a little bit over here to 90. Okay, now the next thing that's going to happen is notice that TH, which is thorium, is also radioactive. So it's not happy turning just into thorium. It wants to turn into something else. So what does it do? Okay, so look at that red arrow, and you see it's got a beta underneath it. So the next thing that's going to happen is thorium-234, one of its neutrons is going to turn into a proton. So notice that the 234, that number doesn't change, because it's true that it got rid of a neutron, but it added a proton, so it's a wash when you add the two numbers together. It's still going to be 234, but it added a proton, so it shifted in this direction to, and now instead of being 92 or 90, so it was 90, it's now going to be 91. So that's going to be its atomic number. Now, I'm not trying to overwhelm you with all of this, but I just want you to see that even the next one, which is, I believe, Pennsylvanium-234, is not happy. It's still radioactive. And so it is going to give off a beta particle, and it's going to turn back into uranium. So you're saying, well, what good did that do? Well, it's now uranium-234 instead of being uranium-238. So that is less radioactive than what it once was. Well, then the next thing that's going to happen is, you can see, it's going to give off an alpha particle and turn back into thorium. and then it's going to give off another alpha particle and turn into radium. Okay, so let me make this larger so that you can see the whole chart on this. So we were up here, and then we changed into these elements, and then we changed into these elements, and now each of these elements is changing at a different rate. So they have their own speed at which they change from one element into another element, and we're going to talk about that in our next segment. But all I want you to see from this chart is you start with one radioactive element up here, and it turns into a whole bunch of other radioactive elements before it finally settles down to lead. So over here, this purple one is lead, and lead is pretty stable, but it's not the most stable. Do you remember what it was? So what is the most stable nucleus there is? Iron. So do you remember that iron will, if you pull it apart, nothing happens. And if you take iron and you smash it together, nothing happens. So this one, lead, is still unstable. But it takes so many years for it to decay, we can say for all intents and purposes that this is a stable nucleus. But really, eventually this thing would decay into iron, given enough time. Okay? So let's take a break, and now we're going to go to our next slide here, and we're going to start talking about how much time does it take to decay from this element into this element. And I'll see you in just a few seconds.